Okay, in 6.5, we're going to be solving square root equations. So before we were just simplifying the square roots, and they were expressions, so they didn't have equal signs, but now we're dealing with equations, so they'll have an equal sign, and we'll be solving for x. So we'll be trying to find what x is in our equation. So we're using what we did all throughout chapter 6 with simplifying the square roots, but now we're just going to be solving for x. So the first thing we need to do when solving for x, we need to isolate the radical. So we need to get this square root to be all by itself. So in this example, how we would do that, we would add k to both sides. So the k's would cancel out on the left, and we would have 0 plus k, which ends up being k. And here we get the radical to be all by itself. So we isolate the radical. The next step would be to eliminate the radical. So we would raise each side to the nth power. So here, whatever this value is in our square root, we're raising it to that same value on both sides. So it's important that it's happening on both sides because we have to keep the equation balanced. So once we raise it on the left side, they cancel out. So we're just left with x all by itself, and then we would have to solve what k to the n power is. So now we're going to do some examples with numbers. Okay, so step 1 is to isolate the square root. So we need this square root to be all by itself. So we're going to subtract 3 from both sides of the equation. So we get the square root of 2x minus 3 is equal to 8 minus 3, which is 5. So now we need to raise both sides to the second power. So they're going to cancel out on the left. So we're just left with everything under the square root on the left side. So 2x minus 3. And then on the right side, we have 5 squared, which becomes 25. And now we just solve for x like we would in any other problem like this. So we add 3 to both sides. So we have 2x is equal to 28. And then we divide both sides by 2. So we get x is equal to 14. And this is our final answer. If we wanted to, we could test our work to see if we did this right, and we could take 14 and plug it back into the original equation for x, and we would solve it and get 8 is equal to 8, which would prove that we did everything right. Our second example, what's the solution of 3x plus 1 to the 2/3 is equal to 12? So we need to isolate our square root here. So in order to do that, since 3 is being multiplied to it, we need to do the opposite. So we're going to divide 3 on both sides. So we get x plus 1 raised to the 2/3 is equal to 4. Now we're going to raise this to the reciprocal of this. So since we have 2/3, the reciprocal is the flip. So we raise it to the 3/2. So we're going to raise this to the 3/2. And we raise this side to the 3/2. So whatever we do on the left, we need to do the same thing on the right. So we're raising both sides to the 3/2. It cancels out on the left. So we're just left with x plus 1. And that's going to be equal to, we have to solve this and find out what 4 raised to the 3/2 is. So over here, I'm going to solve it. So when we have a 2 in the denominator, that's like our square root. So remember, the 2 becomes the index, but since it's a 2, we don't need to write it. So we have the square root of 4, and this is raised to the 3rd power. We know the square root of 4 is 2. So 2 raised to the 3rd power becomes 2 times 2 times 2, which is equal to 8. So our right side of our equation is going to be 8. So I just put that 8 there. One thing that we have to keep in mind here that's super important, if our numerator is even, then this has to become, when we cancel these out, it has to become absolute value signs. So we have to do the absolute value only when the numerator is even. So since we have an even number, this 2 on top, when we cancel the exponents out, it becomes an absolute value sign. And in order to get rid of the absolute value sign, we can drop them by adding a plus or minus 8 on the right side. So we get rid of the absolute value by changing this to a plus or minus 8. So now we can split this up into two equations. So we have x plus 1 is equal to positive 8, and x plus 1 is equal to negative 8. We just subtract 1 on both sides, so we get x is equal to 7, and x is equal to negative 9. So these are two answers here. So when you have a positive number and an even number in your numerator, so when the numerator is even, you're going to get two answers. And this will be the only time that you get two answers is when this numerator is an even number. Okay, example 3. So the first thing we need to do is isolate the square root. So we need to get this to be all by itself. So we can do that by subtracting 1 on both sides. So we get 3. The fifth root of x plus 1 cubed is equal to 24. And then we divide both sides by 3. So we have the fifth root of x plus 1 cubed is equal to 24 divided by 3, which is 8. So on the left side now, I'm going to change this whole thing. So this whole thing, I'm going to change it to a fraction. So we know that our base is going to be x plus 1, so we leave that the same. Our index is what's up front, so that becomes on the bottom. So that's our denominator, and then since it's raised to the third power, that's our numerator. Now I'm going to raise this to the reciprocal. So raise both sides to 5/3. So whatever you do on the left side, you have to do on the right side. So I'm raising both of them to 5/3. Since our numerator here is odd, we don't have to worry about our absolute value signs. We only do that when it's even. So it's just going to cancel out on the left. So we're going to be left with x plus 1 on the left side. And then we need to find out what 8 to the 5/3 becomes. So I'm going to solve this over here. So this is like saying the cubed root of 8 raised to the fifth power. The cubed root of 8, so we can break 8 down into 2 times 2 times 2. We would circle our three numbers. So the cubed root of 8 is 2. Now we raise this to the fifth power. So we end up getting 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 4 is 8. 2 times 8 is 16. And 2 times 16 is 32. So 2 raised to the fifth power is 32. So our final answer here, not our final answer, but 8 to the 5/3 is 32. Oops, 32. So now we just subtract 1 on both sides. So it cancels out on the left, so we get x is equal to 31. And this is our final answer. Okay, example 4. We need to isolate our square root, so we're going to add 3 to both sides. So we have the square root of 4x minus 23 is equal to 2 plus 3, which is 5. So now we need to get rid of our square root so we can square both sides of our equation. It cancels out on the left side. So we have 4x minus 23 on the left is equal to 25 on the right. And now we can just add 23 to both sides. So we get 4x is equal to 48. We can now divide by 4. So we get x is equal to 12. All right, last example. So we need to isolate our square root, so we can do that by subtracting 3 from both sides. So we get the negative cubed root of x is equal to negative 3. We need to get our square root to be all by itself, so we have to get this negative sign to the other side, and we can do that by dividing both sides by -1. So a negative divided by a negative cancels out on the left side, so we're left with the cubed root of x on the left, and a -3 divided by -1 is just 3. So to get rid of our cubed root, we're going to cube both sides of our equation. So it cancels out on the left side, so we get x is equal to 3 cubed is 3 times 3 times 3. 3 times 3 is 9. 3 times 9 is 27. So x is equal to 27. I'm going to do a couple problems from the homework. So let's take a look at number 1. So we need to isolate our square root, so we're going to subtract 8 from both sides. So we get 4 is equal to 12 minus p raised to the 1/2. Raised to the 1/2 is the same thing as saying the square root. So we're just going to square both sides of our equation. 4 squared is 16, and these cancel out. So we're left with 12 minus p. So we can subtract 12 from both sides, and we get 4 is equal to negative p. But we can't have this negative p, we need it to be just p equals. So we're going to divide both sides by -1. Get rid of that negative, so we have -4 is equal to p. The next one I wanted to take a look at was on the page. So number 8. So this is one of those where we have an even number in our numerator. So our square root's already isolated. We don't need to do anything. So we can raise this to the reciprocal. So we're going to raise it to the 3/2. So we need to raise 9 to the 3/2 also. So it's going to cancel out on the left side, but since our numerator is even, we need to include these absolute value signs. So we have the absolute value of x plus 2 on the left, and then we need to find out what 9 raised to the 3/2 power is. So we're going to have the square root of 9 cubed. So I just changed this 2 to the square root. So the square root of 9 we know is 3. So we have 3 cubed, so this is 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So our answer here is 27. So in order to get rid of these absolute value signs, what we need to do is change this to a plus or minus 27. So we are getting rid of the absolute values, and it's becoming a plus or minus 27. So we have x plus 2 is equal to plus or minus 27. And now we can write this as two separate equations. So we have x plus 2 is equal to our positive 27, and x plus 2 is equal to the negative 27. So we're just going to subtract 2 from both sides. So we get x is equal to 25. We subtract 2 from both sides of this one, and we get x is equal to negative 29. So remember, since our numerator was even, our numerator was an even number, we get 2 answers. Sorry your Zoom video wasn't working today. If you guys have any questions about anything I did in this video, feel free to email me. But we're going to go over all of the homework problems on next Tuesday. So the next time I see you guys, which is on Tuesday.